Welcome to today's lesson on finding the area of a triangle using coordinates. This is an important topic in coordinate geometry that has many applications. Before diving into the formula, let's recall what coordinates are. In a Cartesian plane, we represent any point using an ordered pair, x, y, where x is the horizontal distance and y is the vertical distance from the origin. A triangle is formed by connecting three distinct points in this plane. Now, let's learn how to find the area of a triangle when we know the coordinates of its vertices. The formula is 1/2 times the absolute value of a determinant. This determinant involves the x and y coordinates of the three vertices. Remember that the result is always positive since area cannot be negative. Let's understand the formula through a simple example. Consider a triangle with vertices at A1, 1, B4, 1, and C2, 5. Let's plot these points and connect them to form a triangle. To find the area, we'll substitute the coordinates into our formula. Substituting A1, 1, B4, 1, and C2, 5 into our formula, we get 1/2 times the absolute value of 1 times open bracket 1 minus 5 close bracket plus 4 times open bracket 5 minus 1 close bracket plus 2 times open bracket 1 minus 1 close bracket. Simplifying, we get 1/2 times the absolute value of -4 plus 16 plus 0, which equals 1/2 times 12, giving us an area of 6 square units. Let's verify this result using another method. The base of the triangle is the line segment AB with length 3 units. The height is the perpendicular distance from C to this base, which is 4 units. Using the formula area equals 1/2 times base times height, we get area equals 1/2 times 3 times 4, which is 6 square units. This matches our earlier result. Let's try another example to reinforce our understanding. Consider a triangle with vertices at P minus 2, 3, Q 5, 0, and R 1, 4. Let's plot these points and form the triangle. Now, let's substitute these coordinates into our formula. Area equals 1/2 times the absolute value of -2 times open bracket 0 minus 4 close bracket plus 5 times open bracket 4 minus 3 close bracket plus 1 times open bracket 3 minus 0 close bracket. Simplifying, we get 1/2 times the absolute value of -2 times -4 plus 5 times 1 plus 1 times 3, which is 1/2 times the absolute value of 8 plus 5 plus 3. Therefore, the area is 1/2 times 16, which equals 8 square units. Let's discuss an alternative formula that you might find useful. The area of a triangle can also be expressed as 1/2 times the absolute value of x sub 1 times open bracket, y sub 2 minus y sub 3 close bracket plus x sub 2 times open bracket, y sub 3 minus y sub 1 close bracket plus x sub 3 times open bracket, y sub 1 minus y sub 2 close bracket. This formula is equivalent to the determinant form we saw earlier. Here's a special case to be aware of. If the 3 points are collinear, meaning they lie on the same straight line, then the area of the triangle will be 0. You can test for collinearity by computing the area. If the area is 0, the points are collinear. Let's summarize what we learned today. To find the area of a triangle using coordinates, first, identify the coordinates of the 3 vertices. Then, substitute these coordinates into the formula. Finally, simplify and take the absolute value to get the area. Remember, the area is always non-negative. This formula is useful in many applications, such as computer graphics for rendering triangular surfaces, geographic information systems for calculating land areas, and in computational geometry algorithms. Thank you for watching. Practice these concepts to build your confidence.